Now that we have understood gases are made up of molecules, let's understand what are the behaviors of the gas. Okay, now when we talk about behavior of a gas, now you need to understand that gas molecules or gas particles, gas atoms, you can call it whatever you want. Here, since they are very far away compared to solids and liquids, interaction is almost zero, except for the case when they come and collide, correct? That means at low pressure and high temperature, the gas molecules are going to behave by this particular formula, what you're seeing on the screen. Here, P represents the pressure, V represents the volume, T represents the temperature, the absolute temperature, and K is a constant. Okay, now this constant depends on the volume, or you can say the number of atoms or molecules present in that particular container, or you can say the sample. Okay, any one of them. Basically, the value of K depends on the number of particles. Make sense? So, at the condition which is at low pressure and high temperature, any gas is going to behave this way. Now, that value of K is there, right? The one which depends on the volume. That value can also be written in another way, that is K is equal to N Kb. Now, here N is the number of particles and Kb is called as the Boltzmann constant. What do we have? We are going to get Pv is equal to N Kb into T, or we can write this as P1 V1 divided by N1 T1 is equal to P2 V2 by N2 T2 is equal to Kb, because Kb is Boltzmann it's a constant, isn't it? Now what do we have here? P1 V1 by N1 T1 is equal to P2 V2 by N. Now what we can infer from this particular equation is that equal volumes of gases under identical condition, they all behave in the same way. Okay, when I say identical condition, like pressure, volume, temperature, all these things will come. Right? Now this is the Avogadro's theory, or you can say Avogadro's hypothesis. Okay, so it's not exactly a theory, it's more like a hypothesis. Now what he told was Avogadro that 22.4 liters of gas at NTP. Now when I say gas, any gas, okay, at NTP contains same number of molecules. Okay, that is 6.02 into 10 power 23. Now that value is there, right? That's called as Avogadro's number. Alright, 6.02 into 10 to the power of 23. Now, an ideal gas is one which behaves the Charles law, Boyle's law, every law. It's an ideal gas, okay? Basically, however the gas should have been, it's like an ideal case. For an ideal gas, we have the equation PV is equal to mu RT. Now, if in case I take for 1 mole of a gas, then PV is equal to RT. That's what you get. So, R is equal to what? PV divided by T. Correct? Now, R is called as the gas constant. The value of R is, remember, at NTP. Okay? Value of R is equal to 8.31 joule per mole per Kelvin. Okay, now, see, you guys learnt about what is Avogadro's hypothesis and what is the meaning of it. In the sense, suppose if I take 22.4 liters of oxygen at NTP, it is going to have 6.02 into 10 power 23 molecules. Or if I take nitrogen at NTP, that is 22.4 liters, that will also have 6.02 into 10 power 23 molecules. Understood? This is Avogadro's hypothesis. And after that, we started discussing about an ideal gas, correct? Where you have PV is equal to mu RT and everything. Now, since we are talking about behavior of gas, whatever we have discussed so far talks about the theoretical view. Okay. Now, in the next video of the same behavior of gas, you're going to understand about what is Charles' law, what is Boyle's law, there are different types of laws. Okay. And along with the graph, you will understand what exactly we are going to talk about behavior of gases.